Hello and welcome. This is Mr. Los. The purpose of this video is to help you name when the different naming types are mixed together. As I probably mentioned in class when we were talking about this is if the entire page is about a certain type of naming, that makes it quite a bit easier than if the types of naming are mixed together. So there's a couple of resources or things that can help you. One thing that I'm going to make available on Schoology is a naming flowchart, which looks a little bit like this, and I'll show you how to use it. This is not intended to teach you everything you know about naming by any means. It's only intended to just give you the sort of thinking you need to do to get yourself into the right naming system. Now, there's two skills. There is when we see the name in words and write the formula, as we're going to do here. Or, and by the way, on yours, mine is a little more spaced out. On yours, these two items are on one page. Or on the bottom part here, where we see the formula and we write the name. The flowchart, admittedly, probably works a little bit better when we're doing this skill that's down on the bottom. But the sort of things that, basically, there's a few things that we need to be thinking about. Of course, we always should watch out for polyatomic ions. And you'll know there's a polyatomic ion if there's more than two elements. Like here, no polyatomic ion, just chromium and oxygen. On the other hand, though, this one does have a polyatomic ion. I can tell that because there's three elements here, aluminum, nitrogen, and oxygen. So you'll also want your sheet of polyatomic ions handy while we do this, is that you'll be able to identify those polyatomic ions and give them the correct name. So I'm going to do a couple of examples here, a couple from some different pages. And let's actually start here. Start here on on this part where we're seeing the formula and we have to write a name. And probably the biggest issues is, as I said, should we use prefixes? Should we use Roman numerals? Those are the biggest mistakes that people make. Now, this page is only ionic compounds. So see how it says ionic formulas? That means nothing on this page is going to use prefixes. Notice how there's no prefixes on any of these things, and there's not going to be any prefixes on this bottom part. So the biggest thing we're going to have to worry about is whether we should be using a Roman numeral or not. So the flow chart here, so for example, looking at this first one, we got chromium and we got oxygen. So you also need your periodic table if that's not obvious. So let's take a look at our flow chart to sort of help us see how we might think about how to properly write the name here. So going to the flow chart, the first question we ask is there a metal present or ammonium? Because what that's going to tell us is, are we doing ionic things or are we doing covalent things? Now, in the case of this page, the answer is always going to be yes, that there is a metal present. So in the one we were just looking at, chromium oxide, yes, there is a metal present. And then the next question is the metal in group 1, 2, or aluminum, zinc, or silver, specifically those three elements? The reason is because those are the ones where we label the charge in the periodic table, and those can form only one charge. If the answer to that question is yes, we're going to be thinking about this type of naming. If the answer to that question is no, we're going to be using Roman numerals. So in this case, chromium is right here. So it is not in group 1. It is not in group 2. It is not the element aluminum or zinc or silver. So we are in this section of the flow chart, which is we're going to use Roman numerals for the charge of the metal. We are not going to use prefixes, and we are going to make sure the charges are balanced. Now, in this case, since we already have the formula, that we know the charges are already balanced. So I know this is going to be chromium something oxide. What I need to do is supply a Roman numeral that tells the charge of that chromium. Now, this is one of the ones that's a little bit tricky, but let's think about what the charge might be. There are 3 oxygens, which are -2 apiece. There's 2 chromiums. That's a total of -6 from the 3 oxygens. The 2 chromiums have to be a total of +6 to cancel that out, but that means that each one of the individual chromiums is +3. So remember, that's what we put for the Roman numeral, is the charge on each one of the individual chromiums. So you know what I'm going to do is I'm going to take myself out and I'm going to lay this down flat so I can write on it a little bit better. 1, 2, 3. Okay. So chromium 3 oxide, that's that one. Let's look at, let's skip this one and let's look at this one, BeF2. So Be. Be is a metal. It's on the left side of the periodic table. Is the metal in group 1, 2, or specifically aluminum, zinc, silver? Yes, it is in group 2. It's right here. That's beryllium. So looking at our flow chart, the answer to the question is yes. So we're not going to use prefixes. We're not going to use Roman numerals. We're just going to do the plain old naming where we just go beryllium fluoride is what this is going to be. So Be. Fluoride. Okay. Oh, whoops, I wrote that on the wrong line. It should be down there. So just to look at one or two other examples to decide whether you'd write the Roman numeral or not, taking a look at these two. So nickel, if we look at it on the periodic table, we found it right here. So it is going to need a Roman numeral. Remember, the ones that don't need a Roman numeral are this column, or these three elements specifically. So nickel is one where you would need this problem is one where you would need a Roman numeral. On the other hand, potassium and oxygen, potassium being in group 1, we would not need a Roman numeral for this one. Now, if you're doing the top, some things that I would suggest here, probably the biggest thing that people are going to mix up is whether, or sort of recognizing when you're dealing with a polyatomic ion. And skipping the first thing for a second, the first one, because that's a little bit of an exception, the best thing that we want to pay attention to knowing if we're using a polyatomic ion is the ending. If it ends in 8, it is definitely a polyatomic ion. So sulfate is the polyatomic ion SO4 minus 2. And so sulfate is a polyatomic ion, phosphate is a polyatomic ion, and you just have to have your polyatomic ion sheet to know what these formulas are, or have memorized them like I have. Chlorate, that's another polyatomic ion. If it ends in ide, with a couple of exceptions, which I'll get to in a second, for the most part, if it ends in ide, that's going to be the regular, what we call monatomic ion. So oxide is referring to normal oxygen minus 2. There's oxide again, sulfide, for example. So the ide ending is just our regular elements from the periodic table. Now there is 2 polyatomic ions that end in ide. Hydroxide, that is a polyatomic ion. You just have to kind of watch out for that one. It's OH negative 1. And then cyanide, which probably won't come up too often. So that's probably going to be our biggest problem. And then the second thing to remember is if you do see a periodic table, or I mean a Roman numeral, it is referring to the positive charge of the metal. And then since these are all ionic compounds, we need to worry about charge balancing. So sodium hydroxide, well, let's do lead 2 phosphate. So lead is Pb, and the 2 tells me that it has a charge of +2. Phosphate is that. So this is one of these 2 and 3 situations. We would need 3 of the Pb which has a positive 2 charge, and that's going to balance out with 3 of the phosphates. Meant to write 2 there. Sorry about that. And so remember that we don't ever change these subscripts. I had to use parentheses there. When you need more than one of a polyatomic ion, you need to use parentheses. Ammonium sulfide. Oh, ammonium is a polyatomic ion. So ammonium is NH4 plus, and then sulfide would be regular sulfur minus 2. So I would need 2 of the ammoniums, and that's going to be matched up with 1 of the sulfides. Okay, so I want to do just a couple more examples with you from a page that's a further bit along here, past this, past all this, past all this. This one, which is where we have all of the types of naming mixed together. So that makes it even a little bit more challenging. So again, I would suggest, especially on this top part, we're going to use that flow chart to help us. And note the instructions say, on this page, circle the number of all of the covalently bonded substances. So how do we make that decision? So remember, whether a metal is present or not is the key, or technically ionic compounds can sometimes contain ammonium like we just saw. If the answer to that question is no, it's going to be a covalent compound. If the answer to that question is yes, it's going to be an ionic compound, and we're going to be over here. So like, for example, in the case of this page, I would definitely circle these two. Now, that's not all of them. There's more because I want you to look and do some of it on your own. But both of these are nonmetals, as are both of these. So those are covalent substances, and I'm going to circle those. Now, one strategy I might suggest to you, and I'm just going to look at ones from the top half, sort of, just to give you some decision-making to do on your own, is go through all of them before you even start. Decide the type of naming system that you're going to be in, and then maybe name all those at once. Like, do all the ones with prefix naming, and then get that out of your system, and then you'll know, okay, I'm not going to do any more prefixes now. So this is what I mean. For example, with covalently bonded substances, that is the only time we're going to use prefixes. So in the top half that I've drawn here, again, not on the whole sheet, but just in the top half, these are the ones that I'm going to use prefixes on. So I would indicate a little P there, and now none of the others in this top half are going to use prefixes. The next thing I might want to find is which ones need Roman numerals. So remember, the Roman numerals are going to be, if the answer to this question is no, is the metal in group 1, 2, or aluminum, zinc, silver. So neither of these two need Roman numerals because calcium is in group 2. It's in the second column of the periodic table, and potassium is in group 1. So therefore, those aren't going to have Roman numerals, but copper will. Copper is in the middle. Copper is right here. That's going to need a Roman numeral. So maybe I put a little R there and to indicate that I need a Roman numeral, and as does lead. Lead is in group 14. So it is not in group 1, it is not in group 2, it's not one of these three, so that it's right there. And then none of the other ones on this top section are going to use Roman numerals. So therefore that leaves these last two, which are just the plain naming. So then I would suggest that you just go through and name them one at a time. So like this one, that's going to be iodine tetrafluoride. So we use prefixes here. This one is going to be carbon monoxide. Now I'm done using prefixes on the top half, so I'm going to get that out of my system. I'm never going to use them again. And then maybe I name both the ones where we have Roman numerals. So this is copper, so the sulfur is -2. So that means that this copper has to be +2 to balance out that -2. So that's copper 2 sulfide here. Okay, this one has a polyatomic ion. I can tell because there's more than 2 elements here. I have to look up the name of that polyatomic ion if I haven't memorized it, and also its charge. Its charge is -2, and it's called carbonate. Now, this is one of the tricky ones. Notice that there's 2 carbonates. So there's a total of -4 of worth of charge coming from those 2 carbonates. That means this lead has to be +4 in terms of its charge, carbonate. Okay, and then these would just be the plain ones. They don't have any prefixes. They don't have any Roman numerals. So that's calcium fluoride. Notice no prefixes there. Difluoride is wrong. Potassium fluoride. Okay, so then if we're doing the bottom half here, and again on yours, I believe this is all on one page, and mine's kind of split up. You know, keep an eye out for the prefix-based ones. So again, we'll just kind of look at, I guess we'll look at this, this top half. In the top half above here, the only ones that has a prefix is this one. Then we would want to keep, from there, we'd want to keep out for any ones that we see Roman numerals, which there's no in this top part that I've circled here. Then we want to keep an eye out for polyatomic ions. Polyatomic ions are going to end in "ite" or "ate" with a couple of exceptions. So that's a polyatomic ion. Nitrite is NO2, -1. Hydroxide is the one of the 2 polyatomic ions that ends in "ide." But here, when they end in "ide," that's just going to be regular O-2. So calcium oxide, since calcium is +2, would just be CaO. Aluminum oxide, Al is 3+. Then we've got the oxygen. This is going to be one of these where we're going to have to go like this. Lithium nitrite. Lithium is in the +1 column. So it would be like that. magnesium hydroxide. Magnesium is +2, hydroxide's -1, so I need 2 hydroxides. This is where you need parentheses, when you need more than one of a polyatomic ion. On hydroxide in particular, people tend to forget the parentheses. And then xenon tetrafluoride. So remember, when you see the prefixes, just write down what it says. Don't worry about anything. Don't worry about charge balancing or anything like that. Okay, so I think that's it for now. Hopefully that gives you a fighting chance to do this. Be sure to reach out if you have any other questions. But other than that, thank you for watching and have a good day.